This is a video, and it's on building a propane-driven bottle launcher. This video is pretty much just for fun. Some information here. The design is based on the burning and explosive properties of propane, and to learn more about these properties, let's turn this over to Dr. Mr. Butane Fireball.
Hello, this is Dr. Mr. Butane Fireball back with you. I've been gone for a little bit. I apologize for that, but it's good to see you again. Today, we're going to talk about propane. Propane. Propane has the chemical formula of C3H8. It burns at 3,560 degrees. Well, that is so hot. Not as hot as the sun, but it's hot. That's 1,960 degrees Celsius in case you live in Canada or England, or you're in the U.S. and you just want to learn it. Propane is non-toxic, colorless, and odorless. Imagine that. It doesn't hurt you if you breathe it. Well, we all know that. We've been out on a nice spring day and you all of a sudden smell something really bad and, oh no, it's not the guy walking next to you. It's the propane leaking out of your house. So if it's harmless and not toxic, why would they make it smell bad? Well, that's kind of obvious because, if you let propane sit around for just enough time and you let enough air get in there and you put a little spark and boom, yeah, that's the end of that. It always makes me wonder about how propane was actually discovered, Speaking of that, it was discovered in 1857. I sure hope that guy's okay. It was available commercially in 1911. That's when it's made its grand debut. And since then, it's been around since then. Well, they put propane everywhere. They put it in almost every house you ever see. They put it in there so you can run your gas oven. You can run your gas dryer. And if you're not careful, you can blow your house to kingdom come. Propane primarily exists as a liquid and a gas. Now, you can get solid propane, but solid propane is, you gotta be real cold. I don't know how much, but it's pretty darn cold. And because it's a liquid and gas, it's pretty easily transported. It turns from a liquid into a gas at negative 44 degrees Fahrenheit or negative 42 degrees Celsius. Now, there's an important point about that negative 40 something, and that's at negative 40, both Fahrenheit and Celsius are exactly the same. So if you're trying to figure it out, just remember that. If that's the only thing you ever remember, well, I guess you just got to think about cold stuff all the time. It ignites at 940 degrees, which is 504 degrees Celsius, and propane requires oxygen or air to blow up or to burn. If you fill a container just with propane, it will do nothing, even if you put a match in there. That's kind of hard to even believe, but propane only burns like everything else if there's oxygen around. A spark fires off at a quarter inch at about 1,000 degrees Fahrenheit. And that works really good because propane ignites at 940 degrees Fahrenheit. Now, sparks can get a lot hotter than that, but because the smallest sparks do beat the temperature of the propane, it's very easy to ignite, both good and bad. The density of propane is 2 kilograms per meter cubed. It's pretty light because it's a gas. That's self-explanatory, right? Now we're going to talk about propane and explosions because we've been talking about it. Now we're going to focus on it. The ideal mix for propane and air is 10% propane, 90% air. And in our project, because we're going to be working with the air around us, not some oxygen I'm going to pump in there or something crazy like that, but just the air around us, we're going to make sure that whatever we do, we get that mixture as close as we can. Now, sometimes that's just timing, like you got to count in your head or something. But you got to get right or it ain't going to work. If you have pure oxygen, you can have 5% oxygen. That's it. 95% propane. It still works because that oxygen is so concentrated. Oh, yeah. Okay. Well, I covered the explosion part. That's the part of this project that's going to work the best because it's going to make that bottle shoot right off the end of that little PVC pipe there, So I think that's about it. Thanks. Good to see you, as always.
Thank you, Dr. Mr. Butane Fireball. On to the materials. We're going to need a 16-ounce propane tank, which is looking something like this. These are more squat, the green ones that come from Coleman. Coleman also makes the longer ones that are more blue in color, but when it comes to space saving, the squat ones, I like them better. And we're going to need the flow regulator, which is the piece that goes on top that allows you to open the gas and light it. We're also going to need 6 to 8 feet of 1/2 inch clear tubing. You could use 5/8, 3/8 might be too thin, but somewhere in that range. And the reason we want as much of this as is mentioned here is because we're working on the aesthetics of how this looks when it works. You could do this with 3 feet of tubing, but with 6 to 8 feet, you can watch the flame burn along the tubing, which actually looks pretty cool. You need an ignition source. Sometimes this is built into the flow regulator. I'm probably not going to have this. I want to build a separate ignition source, and all that needs to be is a spark, as we learned. We need a frame to mount it on. I'm going to build mine out of wood. We also need zip ties. I think they'll be very helpful, and even some hot glue. In our methods, this is kind of a crude design of what I'm hoping to do. First, build the wood frame with two handles to hold it with. Then I'm going to mount the propane container about here somewhere with the tubing coming off of it, wrapping around the propane container, and then coming up to the top where it will be mated with a piece of PVC here. And that PVC at the end will have the bottle on it. For the spark, I plan on using a battery and a high voltage module. And if you watch my channel, you'll see that I've used these in the past to produce sparks, and a switch. So this will be a momentary switch, meaning once you push it down, you let it go, it stops working, stops the electrical flow right away. So that'll be enough of a spark, which I plan on putting right about here where the gas just enters the clear tubing, to hopefully ignite this tubing, the gas, and have it wrap around here, come up the top, and then blow the bottle off. Because this is just a design in theory, I'm thinking it will end up looking something like this in general, but as I go, I'm certain that some things will not look just like this. Alrighty, let's go on and try and build this thing. Setup is actually pretty simple. This is an 18650 battery, which is 3.7 volts. This is a momentary switch, meaning when you push it, it pops out right away. And this is a high voltage generator module. So these all together create a spark inside this tube. You can see two tiny screws there that I screwed on each side of the tubing. And when I press the momentary button here, you can see the spark, as I mentioned earlier. So what I'm going to do is take this outside at nighttime, fill the tubing with the propane by turning that knob right there, and then we'll spark it and hopefully see the flame go all the way down the tubing. So I brought this setup outside. It's actually nighttime right now. I'm using my camera flashlight, but I want to try this to see if we can catch that flame going to the end of the tube. Camera's in the same place. I'm going to open the gas up here. Give it a couple of seconds. And 3, 2, 1. Camera's in the same place. Let's try this again. 3, 2, 1. There we go. Excellent. This simple wood design is what I am hoping to attach the propane tank to, the tubing, and also the batteries and the switch. I'm going to start this project by zip tying this propane container to the wood gun frame. I don't know how I'm going to keep these tubes from bundling if I pull that zip tie, so I've got to work on it. Over here, I've got the high voltage unit, and I'll be connecting that to the two screws right there, the battery that runs it, and then right here I'll be putting the switch. The electrical portion is almost finished. It's going quicker than I thought, especially with the use of the zip ties. I need to solder the wires together, of course, properly. Holding these in place properly with zip ties was impossible, but it turns out that hot glue, although it's a little tedious here, works extremely well at holding these tubes in line for this project. As I mentioned, I'm going to be soldering these wires together here, but this is not the only way to make two wires come together. There are more modern methods. There are tubes through which you can put the ends of each wire in and then crimp them together. Sorry about all that smoke there. And that way works well. It's really easy, but I'm used to soldering, so this is what I'm doing. These are the two wires I just soldered, and I'm going to put some shrink tubing around it, heat it up, and it shrinks nicely. It strengthens the joint where the two wires meet and protects the metal from hitting other metal. Earlier when I was testing everything, I had wires with clips on each end that would clip different wires together in the system right here, but I didn't want clips. I wanted something more permanent here, so I was able to slide those wires under the screws and then glue them in place. And it's kind of a non-traditional way to do something. Just as a quick reminder, the reason all of this is there in that switch is because the ignition on this particular top does not work. It's why I chose it, because I would otherwise have thrown it away, but in not having a way to ignite the gas, this is what happened. And now it's time to test it. Pull the switch here. Nice. Just have to finish the top of this now. Finish off the top of this project here. I need to do something with the end of this tubing right here. And what I'm going to do is put into something firmer like this PVC tubing right here. And this PVC tubing I'm using because it does fit perfectly inside of a bottle. The top of these bottles is the same size regardless if it's a 2 liter or a smaller one like this. It's pretty interesting, but it makes it easy. So once we fill this tubing with propane, it comes all the way down, partially fills this with gas. There needs to be some air in there, and pull this trigger. This should shoot right off the end. Things need to be fastened properly, but this is essentially how it should look at the end. This is what I hope to accomplish here with mounting that top piece. This is the clear plastic tubing here. This is the PVC pipe. I plan on taking a piece of aluminum, and I wrote out what I'd like the dimensions to be here, which when you add it up is 14.5 inches long, which, gee, I have right here. Anyway, so when that thing's bent into proper shape, I'll be able to screw it down into the wood here, and then zip tie the PVC to the top. That 14-inch piece was bent and screwed in on both sides right here. I just need to get this inside there and seal it good, and then I'll be zip tying this right here. The silicone is cured nicely, so I took this outside to give it a test. I put this bottle on the end there and turned on the gas for a little bit. Then I lit the spark, and the bottle stayed put. But what did happen was this started to smoke, and I think what happened was that bottle prevented any gas from escaping, and it lit forward or backward. I'm not sure what, but anyway, something ended up in there like fire, and it burned a piece. So to be safe, I've got to replace this whole piece right here, and I don't think that'll be that difficult. But up on this end, what I'm going to do is sand down portions of this so that as the gas goes into the bottle, air can escape it easily. As I suspected, this was not very hard to take apart at all. So I'm going to get rid of this, and I have a new one here. It's a flow regulator. That's one solid piece of brass. There's no moving parts, no plastic. Well, this is, but that's even connected to a brass fitting. So it's all metal. I shouldn't have any problems. And I put it on this tank to test it, make sure it worked good, and it works great, actually. So that's going on here. Putting this new one on was super simple. Turns out the end of this flow regulator and the tubing were the same size, so I just put a shrink wrap piece of rubber here and heated it, and it's on there really great. So that's done. I'm going to sand this area here, as I mentioned earlier. It's a little mark to know where to do it, and that's to allow the air to escape out of the bottle as the propane goes in there. Sanding PVC is a real messy job, but I sanded 3 areas, one on the top and one on each side here, with about a 2mm gap on each one. So I'm going to give it a quick test here. Turn the gas on, wait, I don't know, 5 or 6 seconds. And go. Nice. Okay, I'm testing this outside without the bottle first. Open the gas here. And 3, 2, 1. Okay, this is pretty cool. Watching the gas go through all this tubing is really neat, but I did try this bottle a couple more times and it will not fire off the end. And I'm starting to believe that even though it looks cool, there's just too much tubing. So I'm going to remove some and try it again. Taking apart a project that you thought you were done with is never fun, but there's around 26, 27 inches of tubing I cut off, so it's definitely shorter. I have to silicone this shut here. And I think I'm going to keep the tubing just taped in place until I make sure that the bottle works. Nothing over here was really changed, so we're going to have to wait for the silicone, which you need to still put on, to cure. This is actually the end of the tube that we were just firing bottles off, and it got burnt here after a couple shots and expanded. The bottles won't fit over it anymore. So I took a CO2 cartridge, cut off both ends, and I'm going to glue it like this on the actual piece, and I'm going to just use this high temperature silicone to do it. Honestly, this is a bit of an overkill. I understand that. However, I want this to last a long time, and if the end of the PVC continued to get burned, I'd have to keep cutting it, and eventually this pipe would get too short to use. So Let's go try it out. Before this was put on, I was using a smaller bottle to test things, but now that it's on and I'm pretty much done building the whole thing, I'm gonna go ahead and try a 2-liter bottle. Dang. You can even do it with a wide open mouth. These are shish kebab skewers. They're made of bamboo. I taped them on to the bottle I've been using here, so it's obviously going to shoot forward like this, and I'm just going to try to stick it into some cardboard. I will probably put some fins on the bottom here to help it go straighter. This little project is complete. Let's see how it works. It's a thin piece of cardboard that I painted on, and it's a terrible target, but it should work. Ah, excellent. It easily went through 2 pieces of cardboard here, but I almost missed the entire thing. Check it out. I missed the bullseye, but that's okay. It worked. I'm having so much fun. We hope the Russians don't get this.